All right, and with that fateful Zoom voice and announcement, let's get started. Welcome everybody to today's session on ways to use Data Classroom to improve IA scores. Uh, we're really appreciative of you all joining us. Very excited to have a global audience. Feels like a bit of a throwback to the early Zoom days when people were doing everything remotely from all over the world. But thank you again for making time. So, quick introductions to start things off. My name is Blake Blaze. I'm a former United States Navy cyber intelligence officer, currently the director of operations for Data Classroom, and former high school math teacher. My quick origin story with Data Classroom is I was considering leaving active duty service, and when Aaron gave me an introduction to this tool, I was immediately convinced of its pedagogical power. As a former high school math teacher and math major, I saw this as something that could really make math much more accessible to a great range of students. So it's been my pleasure to work with Aaron for the past 3 years as we've worked to develop this product, adding lessons and content. And honestly, the best part for me has been learning from Aaron, who's going to be leading our presentation today. I'll let him give a little bit of an introduction, but I want to make sure he's not too humble as he typically is. He was the type of outstanding high school math teacher who was awarded national research grants in order to pursue the things he was doing in the classroom for the sake of all science. And then, along the way was a TED main stage speaker. So you're with very good company today, and I'm excited again to have him presenting alongside me.
Thanks for the kind introduction, Blake. That means a lot. Thank you.
So quick schedule of events for today's webinar. We're going to lay the foundation, why we're here talking about the IA and why working with data is increasingly important, not only in the context of an internal assessment as a measure of student skills, but also for your students. I'll turn it over to Aaron. He'll showcase some of the graphing features that Data Classroom has to offer, starring mangoes. And then he'll run through what we call an interactive analysis, and this will be something that breaks down important statistical tests step by step and illustrates the different mathematical mechanics that are happening along the way. And then, this is your warning now, there will be a live experiment, and this does require group participation. You don't need to be on camera, but we're going to share a spreadsheet and collect some basic heart rate data and try to discern if there are any insights we can collect while we're on the webinar. Those little notices of the Mango dataset and Cicada dataset are reminders for me to share that in the chat, which I will do in just a moment. And then finally, a quick hint at what our live experiment is going to cover. So the reason that we are here today is that internal assessment is a significant portion of students' grade, right? For whether it's biology, chemistry, physics, ESS, or even math. The internal assessment is 20% of a student's overall grade. And this is a huge undertaking for them. It's, in the case of the group 4 subjects, it's recommended to be 10 hours, a 6 to 12 page paper on largely self-guided study. And so as instructors, this is really difficult to kind of be hands-off and let students carry out these investigations on their own. And so we're dedicating today's time to talk about ways we can help students get the most out of this academic experience.
And I guess, this is a place where I'd like to say, I'm looking forward to taking you through Data Classroom and showing you how I think it can help you with the IA. But I almost have to sheepishly admit that I have never taught an IB course. I taught 7 years in the Chicago public schools at Thomas Kelly High School on the south side of Chicago. And we were an IB school, but IB was a relatively small program within Kelly High School. And I never directly taught an IB course. I did, however, mentor several students through their own IAs for group 4. And got familiar with the internal assessment in that respect. But really, when we were making Data Classroom, I wasn't thinking about the IB program. It was what really sort of had this click, to realize how much we could help with the IB internal assessment was working with a customer here in the United States. It was at a school, Uplift Education, down in the Dallas, Texas area. And this teacher was using Data Classroom, and he recorded some data on his own students, and he just, all of them had Data Classroom available to them, and he just sort of recorded which students used Data Classroom on their IA and which students had not. And then he looked at their scores, and he found that the scores for the students that had used the IA were about 20, or had used Data Classroom on their IAs were about 20% higher. And now if you're a good scientist, you're immediately critiquing that experiment, because those students were, self-selecting to some extent. So you might just expect that students that took advantage of resources they had available to them to do better. But the really interesting part about this teacher's data, and by the way, his name is Brandon Pope, but the interesting thing about Pope's data is he also knew what those students had scored on their ACT, and that's sort of just kind of a general measure of sort of students' academic level. And there was a strong statistical effect of their ACT score on their IA score, which makes sense. If students are going to do better on the ACT, they're probably also going to produce a better IA. But the interesting thing was that the effect of whether or not they had used Data Classroom was stronger than the effect of the students' ACT scores. So it was sort of, even controlling for a student's sort of ability and academic skill level, Data Classroom was having a measurable effect on the student performance on the IA. We don't have that data here, but actually, now that I'm thinking about it, we should, when we send you the follow-up materials for this webinar, we can send a bit of that to you.
Even better that Brandon used Data Classroom to analyze his own class's results. So it's kind of a good.
Yes, yeah, which is very cool. And and by the way, now that district is one of the larger IB school districts in the world. They have I believe it's 12 high schools, and they're using Data Classroom in all of their secondary schools as well as their middle schools now across the Dallas, Arlington area. But yeah, that's so. I just want to, as a presenter, I think it's important, where my background is coming from, and I think it's fair to say I have not taught IB courses, but I have gotten extremely familiar with the task over the last 5 years. That's really where I'm coming from in showing you how I think this can help you out with what you're working on.
And I'll just share kind of one last slide to set the stage before Aaron takes us into a demo about where data fits in to the different subjects' internal assessment criteria. We can see it's a major part of biology, physics, and chemistry with the analysis and evaluation pieces. Same goes for environmental systems and society. And though, in the mathematics IA, different language is used, it's mathematical presentation, use of mathematics, and engagement. And we really think that the ability for students to work with data and work with it comfortably is foundation for all of these subjects. In particular, like I said, analysis and evaluation. In the case of biology, physics, and chemistry, that this makes up, half of the IA's total score. So it's understandable that using an effective tool to really help students reach their full potential had such a demonstrable impact in Brandon's classes. But the same is true really for any STEM subject. Working with data is where the story of that data begins, and it allows students, if they have the right tool, to make insightful connections and communicate that effectively.
Okay, and from here, Blake, are you ready to hand the host over to me?
Yes. You are now the host.
Okay.
I'll transition now to my more familiar role of Master of Ceremonies and of the chat. So if any questions come up during Aaron's presentation, please feel free to drop them in there, and I'll make sure that we get them addressed.
All right. So I guess I just first want to direct you to the Data Classroom website. It's about .dataclassroom.com, or if you are not logged into the web app, dataclassroom.com will also take you here. If you are completely new to Data Classroom, you can click sign up in the upper right to get a free account, and that will give you access to all features for 30 days. And then after that 30-day period, it will just give you access to the free features. The resource library is always free, and the core graphing tools are always free. And if you have any finer point questions about the different packages we have, just let us know. I am already logged in on this tab, and so when you first log in, you'll come to a dashboard that looks something like this, where you'll have kind of help resources in the four main areas. This sort of lesson plans, easy graphing, working with your own data, and statistics. Those are linked to help pages and help resources to help you get familiar with the tool. One thing I'll say as I'm doing this demonstration, everything I'm showing you, you should keep in mind that your students will be able to put in their own data and work with it in the ways that I'm going to be demonstrating. However, I'm going to pull from our resource library of data sets, which is what you see here. These are data sets on a pretty wide variety of topics: biology, chemistry, physics, even sports, economics, social science. And so there's just pages and pages of data sets here for students to work with. I'm going to demonstrate with this data set called Too Old to Mango, and it's investigating the impact of mango tree age on fruit traits. These are data that were collected by an agricultural institute in New Delhi. And I believe there's links to the sources in there, but this is real world data, as are many of the data sets in our resource library. So I'm going to open up this data set and just kind of get you oriented to what a data set is in DataClassroom. This is the table tab. So if you're looking up at the white bar at the top, we've got data organized in these three tabs: table, graph, and assignment. The table tab has the data itself, and I can collapse that just so you're looking at the data. It always shows a header of 100 rows, and if it's more than 100 rows, you can see data page by page for through the whole data set. I'll make this come back at the top of the screen. You see this flow chart where it's the workflow for working with your own data. There's preparation, visualization, and then statistics if you want students to go that far in their analysis. That this is the workflow. I'm going to come back to this and show how this can help students in working with their own data, and I'll go back to that after I've kind of demoed the core stuff, so you can kind of get oriented to what DataClassroom does. So this is the table tab. Up at the top, moving over to show you the assignment tab, and I'll actually open that in a separate browser window. And this is the student facing assignment. And it is technically it is an embedded Google Doc, so it makes it very, very easy for students and instructors to edit. So you as a teacher, if you want to customize this, you can click save a copy and save your own copy of this public data set. And then you can click the edit pencil, and it will open up a Google Doc where you can change anything you want in that Google Doc, and those changes will be reflected right here in this document that I'm scrolling through. The student-facing documents always have the background on the data set, framing the question and maybe its importance. The notes about the data set, say where the data came from. And this, for example, these came from the Agricultural Research Institute in New Delhi. Why they were collected, a few notes about how they were collected. It also has a link to the original scientific paper here if you're interested in seeing that. Then the variables get defined, and then there's activity questions for students to work through. So all of the pre-made stuff in the resource library, basically it follows this formula. I also want to point out that some of the data sets in the resource library are fairly complex, and there's room to do additional exploration beyond what is in the pre-made activity. So if a student really takes an interest in some particular data set and they want to explore that in their IA, there's frequently other directions they can go beyond just what the prescribed questions we have are in the activity. And from here, I'm going to move over to the graph tab, and I'll say, just want to encourage that if you have any questions at all, please feel free to drop those questions in the chat. Blake is pretty good about stopping me and preventing me from monologuing too long if we have questions. So if you do have a question, feel free to drop that in the chat. Okay, so here we are now to the graph tab. I showed you table, then assignment, and now we are at graph. This is the heart of the DataClassroom tool, and it's built around the philosophy that you should explore your data visually. And that is advice that I stand by, whether you are teaching year 6 students in middle school, or you are teaching, a second-year PhD student to work with data. It's something that applies at all levels. And so to show you, if you want to plot a variable, so we'll take like total sugar percentage, and you can see when I hover over the button, it tells you what it does. This button that says show will graph this column. When I click it, it will graph that column. And our default is a what's called a jittered dot plot like this, where each data point, each row in the data set is visualized there. Each row in this case is representing a different mango tree. And this control panel at the right is smart, and it starts giving students options to modify their visuals as they might become relevant. So they will not see all options when they have this variable up. They will only see options that are relevant to this. So I can do things like, if I want to visualize this as a histogram, I just changed the icons from graphs made with dots to graphs made with bars. And we see for this numeric data, this produces a histogram. And so we can see the distribution of total sugar, and we see we basically have a normal distribution of this variable. It's very easy to iterate through variables. So if I say add calcium content and potassium content and magnesium content, you see those variables queuing up in the control panel at the right. And if I want to look at a different variable, I just switch where my red X is. So now I put it for calcium content, and I can see what the distribution looks like, or potassium or magnesium. Potassium's kind of interesting in that it looks like we have this bimodal distribution here. So I'll drop the normal overlay on that. But you can see it's very easy to iterate between graphs of different variables. This was something when I was teaching was kind of frustrating to me. When working with spreadsheets, this is always challenging for students to do in Excel, and we would kind of get lost in the button pushing, and it wasn't easy to just look at a bunch of different graphs in succession. I'm going to go back to this style of graph, this dot plot, and I'm going to build some complexity here in adding a second variable. So this is just looking at all samples of total sugar, but we might want to compare these across tree age. And this tree age has been recorded as a categorical variable because they planted them in 3 different sections of an orchard, where they have 6-year-old trees, 18-year-old trees, and 30-year-old trees. And so it split that big pile of data points up into 3 categories. And again, if I wanted to see, instead of looking at these 3 categories instead of total sugar, but I could really easily, look at, well, here's what it looks like with calcium, and here's the story for potassium, and here's the story for magnesium. So you can again really quickly iterate through those things. And then if I want to add other options to this, I can look and see things like, adding descriptive statistics. So now it's plotted mean and error bars, where the error bars are standard deviation, and I can further change, through other options there, and say, hey, what would that look like as 2 standard errors of the mean? And I can switch to those error bars and see, oh, 2 standard errors of the mean, those are pretty tight. But we see, looks like some clear differences between groups, especially, the 6-year-old trees look very, very different from the 18 and 30-year-old trees, which will look, more similar to each other. I can also do, instead of a mean and error bars, we could do box plots with like a median and interquartile and the range. I'll go back to the mean and error bars there. Um, Blake, I just want to pause. Any questions in the chat at the moment? You're muted there.
For the millionth time. None so far. I'm just anxious to see the data emojis.
Oh, yeah. Okay. So this will be a good opportunity to show you everything about this graph appearance wise, can be customized. And so at one of the simplest things you can do is choose a different color for each category. So like in here, you can see where I've chosen these custom colors, and instead of this yellow green, I could choose blue for this if I wanted, or I could even do it as a custom color and maybe make those points semi-transparent. And so you can see, here you see that color change. If you want access to even more things of about the appearance, you can come over here to this button on the control panel. And again, when you hover on the button, it tells you what it does. But when we open it, I can control just about every aspect of this plot. I can do things like reduce the point size. I can do things like I can add a title to my graph. And then this is my title. So I can change, just about any visual aspect of this. I can also, what Blake was mentioning, instead of representing points with dots, I could represent these with symbols. This is actually there's I'll make those point size bigger again, but this symbol is actually a mango. This library of data emojis has 3,600 symbols to choose from, and it's searchable. And so like when we search mango, you can find a mango fruit. Like, I don't know if I had actually seen the mango emoji. It looks spot on though. It immediately looks like a mango. I like it. So you can do that and have some fun with the way you're representing the data visually. I'll go back to the boring old dots there for a second. But in this way, you can get this graph to look, just about any way that you want it to look. And if you want your students to then, place this into their IA document, I can click this camera icon in the upper right, and this will place the image on the clipboard. And then if I'm working in a document, like say this Google Doc, I can paste that in and take my image over there as I go. In addition to the image itself, I can also ask for these values by checking this box. And this is all of the summary statistics of the data for each of the groups in this little table. So you can see for each of the 3 tree age groups, it reports the mean, the standard deviation, the standard error of the mean, the confidence intervals, the median, the minimum, the maximum, and then the quartile limits. And again, I can place that table on my clipboard. And if I want to include that as part of my IA, I can paste that table. That's also a live table, so I can go into cells and do additional calculations, or if I wanted to place that in a spreadsheet for some reason, I could do that as well. One other thing I want to show from here, and then I want to circle back and show some of the helps, because I've just been jumping in and using the tool, but there are some more helps built in for students. And one of the helps that's built in is if a student needs help deciding on an appropriate statistical analysis for data, we like them to graph it first and then recognize that they've actually done a lot of intellectual work to frame this question, right? Because whether they can verbalize it or not, they're really framing this question as, is there a difference in magnesium content between these different tree age categories? And so this button right here, over right by the appearance button, is the graph-driven hypothesis test. And when I open this, it opens up the suite of different statistical tests. And using the information that the student has already provided by making the graph, it knows that the only appropriate test for these data is the ANOVA. And this is because we have this categorical variable, which is tree age on X. It has greater than 2 values. It has 3, 6, 18, and 30 years. And then we have this Y variable, which is numeric magnesium content. And so when we go to calculate, it will give the students a stop and think moment explaining, why are we using the ANOVA test? When should we use it? Well, this test is testing for a difference in the average value between 3 or more different groups. And that is, so that explains it at a very basic level. And then how does it work? Well, it's weighing the difference between the means of the groups, which is the signal, against the spread of the data around those means, which is the noise. And it's determining whether or not this difference is likely to be the result of random chance or not. And that's what it does when it's calculating a p-value or a probability value. And you can see I can get that output, but instead of just dumping that output on a student who's not familiar with it, we try to frame it and give them context, which makes DataClassroom kind of unique as a statistical tool.
And also too, Aaron, there's the explanation of what a p-value is, so that the student has more than just the regurgitated language of statistical significance. Because in order for students to get that 6 in at least the group 4 subjects in the evaluation criteria, they need to correctly justify their conclusion, and that's going to mean using more than just numbers. And so we try to provide the scaffolding throughout the tool to give students the ability to cite the context and explain why the results they've calculated have meaning.
Yeah. And you can, to show where you can get a little additional explanation under this interpretation of P, it says explain. And if I click on this, it really frames the question, the mathematical question in this blue box. It shows the p-value on a number line, from all possible values from 0 to 1. And then the rest of the text on here is helping students to put this p-value in context. I'm glad you brought that up, Blake, because that is what I hear from teachers, is that they're like, we did statistics in our IAs before, but I felt like students never really could explain what they did, and DataClassroom is helping them to do that. You can also see that this p-value is a slider, and I can see what other values in the parameter space, how those would be interpreted. But when I let it go, it's on a digital rubber band, so it always goes to whatever value was calculated. And in this case, it's less than 0.01, interpreted as that these groups are different. And really, this means that there's less than a 1% chance of getting data that have differences like you see here in the graph, if in fact there was no real differences in magnesium content across tree age. So here, this is pretty strong evidence that there are differences here. And just to kind of give you a full picture of how that graph driven test works, if I make a very different graph, for example, say I want to look at how calcium content and magnesium content are related, if I go into graph driven test now, instead of an ANOVA, we're now looking at a linear regression, because we're looking at a numeric variable. And so when we get our pop-up window, it's explaining that, well, this test is used to look for a relationship between 2 numeric variables, and that's what we're doing. And again, we go to the stats, we get a slightly different output because there's different parameters that come out of this test. But again, all of the scaffolding there is set to support students, and it's really set there to support students' autonomy in these kind of analytical tasks. And I know the IB, when you look at the language around the internal assessment, they really do push what an independent task this is to be for students. And I know in practice that there's all sorts of mentorship that students and faculty are giving students, but at its heart, it's meant to be an autonomous task for students. And I think that these tools are also, sort of coincidentally meant to help support students as they analyze their data on their own, not someone doing it for them, but students sort of working through the process and drawing their own conclusions as they visualize and analyze their data.
And if I could just ask a quick question, I know when I was in my high school math classrooms, I had a lot of students for whom a regression was a reach for them, and to begin to to be able to begin with the end in mind, as you have to do when doing an experiment and designing at the start. It requires iterating through making graphs and doing an experiment. What ways can DataClassroom help the student who hasn't yet developed a familiarity or a comfort with different graph types?
Yeah, I'd be happy to show something on that front. And so what I did here is I just jumped straight into the graphing tool, and I don't know how many different graphs I've made in this demo already, but just went through a whole bunch of different ways to visualize your data. But let me just clear this off and back up a bit. If I go back to this table view, there is this flow chart that begins with data preparation. So that work with data begins in organizing the data in a spreadsheet. And this is all done. So you can see these green check marks. And if I open one of these, you can see the things that we're asking students to do. Have they, does each column have a variable type set? Are the values short enough to fit on a graph? Are the categorical values unique? So they can look at these, and for any of these, if they don't know what they mean, they can click on these checklists that help guide them through. So what is your variable type? Well, we'll explain the different types. We'll cover some tricky cases, and students can work through that. But in particular, Blake brought up, graphing help. And if I go to the visualization step in this workflow, and I open the graph wizard. So it shows me, one, I can just jump to the graph if I want, and that's what we already did, or I can open this graph wizard tool, and it's a stop and think moment. It says, okay, well, we'll help you make this graph, but in order to do that, we really want you to think about, what are you trying to illustrate? And this is the process that experts go through almost without thinking about it. Are you trying to illustrate proportions? Are you trying to show change over time? Is this question about distribution or variability? Is it comparing groups, or is it a relationship? And, for example, I'll do a simple proportions question. Say our question is, I want a graph to show, was my sample size the same for my three main categories, the 6-year-old trees, the 18-year-old trees, the 30-year-old trees? Well, that's a proportions question. And so I can go down here, and then I need to think about, am I looking at just how one variable is distributed, or am I looking at two? Well, I'm really only interested in tree age. So I'll go here, and then I'll name that variable. And now it shows me, well, there's actually 4 different ways we could show that, answer that question visually. We could do it with a pie chart. We could use it with a bar graph. We could do a stacked bar, or we could do this bubble. And students can pick, whichever one. Sometimes they tend to gravitate toward ones that they're comfortable with. But what I really like is when they see this and say, oh, I didn't know I could do it that way. Maybe I'll look at this bubble plot. I wasn't, I was unfamiliar with those. And it can set that up for them. It can go click by click and show them how to get to that. Or you can say do all, and it'll just auto go through that and set that up. And, now I've got tree age, and I can see I have 160 samples in each. So, yes, I had equal sample size, but this doesn't have to be my endpoint. I could see, what that would look like if it were bars. I could see, what would that look like if it was a pie chart. And I can toggle back and forth between those options, or I could even go in and say, actually, make that a stacked bar chart, and I can, see it that way. So there's still a lot of different ways to look at it, but that graph wizard will scaffold a student as they're unfamiliar in making a graph. You'll also notice when you make color choices, it will preserve those across different graph types. So like when I was showing you choosing that transparent blue color for the 6-year-old trees, it will preserve that to any graphs. That's also really handy when a student is presenting multiple graphs within an IA document, and it helps for comprehension of the reader when you keep color schemes the same across different graphs. All right. At this point, Blake, would you like to go on to interactive analysis, or would you like to show our, do our own experiment and show a little bit about how people can get their own data into the program?
I would love to do the live experiment now. Make
Okay,
sure it remains engaged.
we'll go ahead, and I'm going to let you run this, but I'll flip over to my screen where we have this Google Sheet set up.
Sure. So, Aaron, if you'll tab over into the webinar experiment, I've added uh, the column for name is just everyone who's currently in the chat. So everyone in the chat, everyone in the webinar, check the chat. I just dropped a link to this spreadsheet, which should be shareable to all. We're going to do a live experiment where we just check our heart rate and see if there's any impact that can be explained by age or the number of cups of coffee we've had today.
And Blake, you want them to click that link that's in the chat right now and go into this spreadsheet, right?
Yes, it should be freely shareable to everyone. And on my mark, I'll have everyone track their pulse for 15 seconds, multiply that by 4, and then put in their heart rate. I'm just pulling up my timer now.
All right, so I'm ready. I don't know if everyone else is ready, but I'm ready. I've got my hand on my.
I'm sorry, Aaron. I shared it only to you and not to everyone.
Okay.
I was
open that up. That as much as I use Google products, I always seem that not getting the sharing settings right is something I frequently do. There we go. I see all the anonymous animals entering. So, okay, so all right, I've entered my age there.
all right. For those of you entering your heart rate, if you're wearing a device that monitors it, great. We can trust that. Once I see a few more ages dropped in, I'm going to start a 15-second timer. And so for those of us not wearing a pulse counter, we can drop those heart rates in you. But kudos to those of you healthy enough to be tracking it in real time.
My cups of coffee, I've only had one, but it was this size, so I don't know how to count that. If that's at least 2, maybe 3.
What's good, we can note maybe there might be some bias when we assess our results and consider the data processing.
I guess if we're counting 8-ounce cups, I guess it's probably 2.
Okay, for those of you waiting patiently to do the timing, I'm going to start in 3, 2, 1. And stop. So take that number, multiply by 4, drop that in your heart rate.
All right, I've got mine entered in there. We've got a couple who haven't entered anything. Either maybe we're having some trouble getting into the Google Doc, or they've gone to attend to something else and left the webinar running.
We're just passively consuming the content, which we will take no offense to.
Yeah.
But that's great. We can let's give Raj another second to get their heart rate in. Right, Ali's pointed out they've gone to make their coffee.
Yeah. Okay. While they're still entering into this spreadsheet, I'm going to go back over to DataClassroom for a second and show you how your students will bring in their own data. This, by the way, sometimes we get the question of what does the student view of DataClassroom look like versus what is the teacher view? The answer is very simple. They look almost identical because it is first and foremost a tool. And so that the set of tools are pretty much the same, whether you're a teacher or a student. I'm going to go to the dashboard. And so to get back to the dashboard at any time, underneath your username, which is always in the upper right of every screen, you'll see the little house icon that says dashboard, and it will take me back. It will ask you if you want to save any changes that you made. I'm just going to discard these. These were just for demo purposes. And I'm going to come back to the dashboard. Scroll down just a little bit on my small screen to this green button that says import. And when I click this, it will give me options for where I want to bring the data in from. I can also look at format tips, and you can see this is how we would like you to set up a data set. This, by the way, is called tidy data. This is pretty much the universal format for data in the world of data science, the world of professional science, increasingly the world of business as well, as business becomes a lot more like the sciences in the way that they organize data. So, you know, your students might find this just a little bit of work at first, but teaching them to organize their data in this format will pay dividends in their future academic studies or career. And I'm gonna choose the option to fetch data from a spreadsheet on Google Drive. You can also upload an Excel or CSV. You can copy paste in data. You can create a blank data table, but I'm going to go to this fetch, and it's going to ask me for the link to the source spreadsheet. And I'm going to go and I'm going to grab this sheet, and you have to have permission. It has to be a sheet that has actually been shared with you. But then when I go and do that, I can go ahead and I put the URL in. I just copied it out of the browser. I put it into that link to source spreadsheet, and I click fetch, and it's talking. And I'm just going to give my file a name here. This is the heart rate analysis for webinar, and it's brought these data in. And so now it starts me through this checklist. I'm on the flow chart in the preparation part. And all of the first things for data import we're good to go. I've got a column header for everything. My column headers are short enough to work with on graphs. So I come in here, and now you can see we've got a caution triangle on the preparation phase of this. So I'm going to go ahead and prepare this. It's telling me I'm missing a description of my data, and I need to set my column types. And again, if I'm like, what's a column type? I can click learn more, and it explains a little bit about what they are. And so now I'm going to go and say, I'll fix this. So first thing I'll do is give it a description, and I'll, say live data set from our webinar. And that's a note for future meet. And, if I ever open up this data set again, I know what it means. And I can go in and say, choose what these types are. And these are names. And I could say, okay, these are identifiers. And participant ID, again, this is just an identifier. Heart rate, this is numeric data. Age, this is numeric. Cups of coffee, this is numeric. Coffee, yes or no. These are categories, and I'll leave that. And also this column where it saw a column header and pulled it in, I'm just gonna right click and sorry, I got my Zoom tools in the way. But I'm just gonna, cut this, or if I go over here, I can add, delete rows, columns, and I'm going to remove one column at the end. And so I just did that, and now I just cut that column off. But I've got my data fully prepared to work with, and you see that my checklist went to green. You also notice that there's some of these caution triangles are not clear. And when I hover on it, it tells me, what the problem, and it just says, you have some missing data here. It's not preventing you from doing any work, but it's just pointing that out. And that can actually be quite useful to students when especially if they're working with a larger data set to, and they can click find those problems, and it can go through and go to those values that are missing and see if something needs to be addressed. In this case, I'm fine with missing data. We know the reason why the data are missing, and that's fine. And we can just go ahead and analyze the data we have. I can go, over to the graphing tool, and I can let's look at age, and let's look at heart rate, and, maybe let's flip that around. Let's put heart rate on Y, then age on X. Doesn't look like we have a tight correlation. We have, maybe a little bit of a negative slope, but it looks like, judging by the R² value, it looks like, age is only explaining about 2% of the total variance in heart rate. So that's relatively low. We could, split this up in another way. let's look at, let's look at coffee, yes or no, as a category. So if we put that on X and we look at, coffee, yes or no, we can add some descriptive statistics here, maybe 95% confidence intervals. Again, looks like no statistical difference. It is interesting. That looks like a lot less variance on the yes side of the categories. But again, we have a relatively small data set that we're working with here. We could even, if we wanted to like overlay age on top of this, we could look at age with the darker points being older folks in the group, and the lighter colors being younger folks. I don't know that reveals any patterns there either, so I'll probably take that away. But you see, with working with your own data, the other thing I want to show you is when you bring in data from a Google Sheet, and so say you have a situation where you have your entire class over here working, and they're all collectively putting data in here, and then one student says, wait, I want to add my own data here, and I make a new row for this student, and we'll say this student is 16 and they had 5 cups of coffee this morning, and that's a yes. And say they added that additional data to that. If I go back to my data set, I can get this slide out menu on the left, and I can reload, and it remembers the address of that Google Sheet, and I reload it, and it brings in the most recent version of that. And so, like, really quickly, if we look at we'll put age on X again, now we can see here's that data point from that 16-year-old student. It's been added in, and just puts that data into the data set as we go. So that's I tend to like bringing in data with that Google Sheets integration, because I can do everything that Google Sheets does well, and then I can bring the data into DataClassroom to do all the analysis and visualization with it as well.
And Aaron, one thing that jumped out to me the first time you gave me a demo of DataClassroom, it still resonates now, is just how quickly students can go from their own data to seeing different visualizations. And so the story begins to become apparent before they have to turn their assignment in. With Excel and with Sheets, graphing is not as easy. And so oftentimes it's the end of a student's analysis. Whereas in this case, it can help be the beginning. Like we saw a couple of trends emerge right away. There's something maybe even counterintuitive about heart rate dropping as age goes up. So I would, if I were a student, like, okay, I need more subjects on this. I might know which ages to investigate. And then for the yes, no question, I see, okay, the mean looks substantially different, but because of the variance in a small group, I can't say with a lot of confidence that they're different. So I'm going to take from that, okay, I need more test subjects to continue my investigation. And just by decreasing the amount of time it takes for students to go from data collection to the visualization and story finding, they can spend more time on the more important part of analysis.
Yeah, absolutely. And that's definitely something we're focused on. Like we want students to be having more conversations about what their data mean. We want them to be writing more nuanced conclusions. And I think a lot of that starts with really understanding your data set, and by looking at it visually and look, in different ways. That point about like bringing in the data visualization and the graphing early into the analysis is something that I'll say, not only do I believe in that pedagogically, but as a scientist. So I, after my time in the classroom, I worked as an evolutionary ecologist, field ecologist for a little more than a decade. And every time I analyzed a data set, it always started with the visuals. Like that was always what we was doing. And every paper that I've ever published, the part of the manuscript that was written first was the data figures. So I always start with what are the graphs that I'm going to include, and then the entire paper is really like support for that result. Is that when I was writing the introduction or the results section of the discussion, it was all built around those data graphs and those data figures. So I can't emphasize enough how much I think that doing your figures first can support good analysis and then clear communication of your data, which is exactly the concepts or exactly the measures that are graded on that analysis section of the IA rubric. Yeah.
Well, I think we may have time. We could do with this data set or with the cicadas to take a quick look at the interactive analysis too.
Yeah, we could do that. I'll probably pull up the cicada data set. So one last thing that we want to show you is the interactive analysis, which if you remember from the flow chart, this was, instead of the graph driven test, this was another option under the statistics portion. And this is what you want to do if you don't just want students to just kind of crank through their data and get a result, but you maybe the point of some point in your course, you want to actually have them learn a little bit about what a statistical analysis does. This is a good option for that. And so what I'm doing now is I'm saving my own copy of this, and I'm going to go into the interactive analysis, and we're going to do a t-test that's looking at is there a difference between the sexes in head width, and mind you, these are head widths measured in millimeters, and these are cicadas that we're talking about. So when we say male and female, we're talking about male and female cicadas. If you don't have cicadas where you live, these are the small insects with big eyes and noisy wings. But we'll go ahead and look at this data, but you don't actually have to be familiar with a cicada to watch and learn from this. So you can see I've stated a research question, is head width different between female and male cicadas? The computer was suggesting a research question based on the variables that we chose, and I added to that. And then it will open up this where we can walk through how these calculations are done. And the first three things we're going to do are just visual estimates. So first, we're looking at this with our eyes and saying, are the groups different from one another? And I'm grabbing this slider and I'm just putting it where I think it belongs. I don't need to have a thorough understanding, but it's just asking me the question of, do you think these look different to you? Do these groups look like they're, different distributions? And I can log that into my lab notebook later on. This can be a document I can take out. But then the same thing is, where do you think the mean is for each group? And I can grab these bars that are sort of slowly oscillating and place them where I think they belong. Maybe the mean for females is there, mean for males is there. And then the computer will calculate those and give me real-time feedback on how I did. Most people are actually very, very good at this task. You can see I got the mean for males to within a hundredth of a millimeter. Most people will tend to do, pretty well on this task. And then we do the same thing with variation. So we're asked to estimate the standard deviation. The text is coaching them to grab the shaded bar and cover 2/3 of the data points. So I did that. And now we can see, what the standard deviation is for each of these. And now as we go through and we calculate the test statistic and get our p-value, we're seeing where those quantities come from. So here's the difference in means, and it's highlighted with those gray arrows. And then now we're taking this measure, which is called group variance, which again, I can see the equation for group variance, but for an introductory level, I think the more important thing is to understand that this comes from the spread of data around the means. And that's what we've illustrated with those shaded bars. And now when we calculate the t-score, which is literally just the difference in means divided by the group variance, we can see this dynamic scale is heavily tipped toward the difference in means, saying that that's outweighing the variation around those means. And so we count up sample size, and this will show us, where we can calculate the p-value, and we get, in this case, a very small p-value, just like the other example we showed. But hopefully the idea is here a student now understands a little bit where that math came from. And again, this is, when we're doing those graph-driven tests, that's a different situation. You're just, you're doing an analysis, maybe you're cranking through many different analyses. It's sort of a workhorse kind of tool. this is much more of a slow down and think teaching tool if teaching the math behind the statistical test is the goal. This is the version of the t-test that I think you should use. Yeah, and that's I realize here we are about out of time. I know people have schedules, and we're actually from all over different time zones, so I don't want to assume what you have next. It might be your evening, it might be your middle day. But yeah, I think with that we'll come close to wrapping up here. I'll go back to the slides and show that last slide here, where if you want to get in touch with us, we would be happy to talk. So please feel free to drop us a line. You can see my email there and Blake's email as well. Blake, do you have any parting thoughts before we wrap up?
No, just a thank you to everybody for participating. We put a lot of thought in trying to make these webinars helpful. We'll send out a link afterwards for any feedback on how we can improve on future ones, but appreciate you being here, and I would love to help in the future.
Yeah, excellent. Okay. Well, with that, then I will say thanks for coming, and hope to see you at another webinar down the line.